All right, let's talk about something that can either be a superpower for your engineering team or a total nightmare: CI/CD. We're going to cut through the buzzwords and get real about how you build a system that turns software development from something stressful into a serious competitive advantage.
Oh man, we've all been there, right? You feel that knot in your stomach, that pre-deployment anxiety where your entire weekend is hanging by a thread. That feeling, that manual, error-prone, high-stress situation is exactly what a good CI/CD process is designed to completely eliminate.
So, here's how we're going to break it all down. We'll start by digging into that deployment nightmare. Then we'll build our way out, step by step. We'll cover the basics of CI, map out a full pipeline, clear up the whole delivery versus deployment confusion, and then get into the tough stuff, surviving production. Finally, we'll talk about why this is all so worth it.
Look, before we can appreciate the solution, we have to really feel the pain. We got to understand why we even need this stuff. And it all starts with that old-school manual deployment process, a system basically held together with duct tape and crossed fingers.
I'm sure this looks painfully familiar to a lot of you. It kicks off with a code freeze, nobody touch anything. Then it's the all-hands-on-deck manual test marathon, where everyone scrambles to see what the new features just broke. The deployment itself, super stressful, usually falls on one senior engineer who knows the magic commands. And then, once it's live, you just sit there, hitting refresh and praying.
And this is the daily reality of that mess. You're living in merge conflict hell because changes are huge and infrequent. The main branch is basically always broken, so nobody can get any real work done. That one senior dev becomes a huge bottleneck. You've got people asking around for server passwords, or even worse, manually editing config files on a live server. Of course you're terrified of Friday deployments.
So how do we start to fix this? We go right back to the beginning, to the code itself. The very first step to getting your sanity back is continuous integration, or CI. It's all about stopping that collaboration chaos.
You know, CI is really built on a question that's so simple, it's almost brilliant. Why are we waiting until everything is smashed together to find out if it's broken? Why not find those problems way earlier, when they're small, simple to fix, and we know exactly who introduced them?
So here's the key thing to get. Continuous integration is a practice. It's a habit. It's about getting developers to push smaller chunks of code way more often. And every single time they do, an automated process wakes up, builds the code, and runs the tests. The whole point is to get feedback instantly, not in 2 weeks during a code freeze. Just look at this contrast here. It's night and day. It shows you the massive impact this has on a developer's daily life. We're going from the chaos on the left to the confidence on the right. No more merge hell, just small, easy commits. No more finding some tangled, complex bug a week later, we catch it right away. This is a shift from pure frustration to real, genuine confidence.
Okay, so CI is that solid foundation, but it's just the first piece of the puzzle. Let's zoom out now and see how CI plugs into a full, end-to-end automated pipeline. A system that takes code from a developer's laptop all the way to a finished, deployable package.
It all starts right here, at the source. A developer pushes their code to a place like GitHub or GitLab. That single push is the trigger. A webhook, which is basically just a little automated notification, gives our CI/CD system a tap on the shoulder and says, hey, we got new code, and the whole pipeline roars to life.
But hey, even before the pipeline gets going, we can build in quality. Things like branch protection rules make sure another human being has to review the code. Linting automatically catches simple typos and formatting mistakes. And even better, pre-commit hooks can run these checks on the developer's own machine before the code is even pushed. That's the fastest feedback you can possibly get.
Once the code's in, we hit the build stage. This is where tools like GitHub Actions, Jenkins, or GitLab CI take over. They grab that source code, pull in all the libraries and dependencies it needs, and basically assemble it into something that can actually run. For most modern apps, this usually means building a Docker container image. Okay, the code builds. Great. Now comes the most important quality gate of all, automated testing. This is where the pipeline proves that the new code actually does what it's supposed to do, and more importantly, that it didn't break anything else. And the best part? It all happens automatically, with no human intervention.
Now, not all tests are the same. You've got layers. Unit tests check the tiny little bricks of your code. Integration tests make sure the different walls you built with those bricks actually fit together.
And then, end-to-end tests are like a final inspection. They simulate a real user walking through the entire house to make sure everything works from start to finish.
Modern pipelines go even further. We're not just checking for bugs, we're checking for vulnerabilities. This stage uses tools that act like a security guard for your code, scanning for common security holes, bad practices, or even secret passwords that a developer might have accidentally left in. Finding this stuff here is 1,000 times cheaper than dealing with a breach in production.
So, if the code passes every single build, test, and scan, what do we get? We get an artifact. You can think of this as the final, sealed, versioned, ready-to-ship box. It could be a Docker image, a Java file, whatever. This thing is the certified gold output of our pipeline, and we store it safely in a repository, ready for deployment.
Hey, just a quick pause. We just walked through that entire pipeline, from a single line of code to a ready-to-deploy artifact. If this deep dive is actually helping things click for you, do me a favor and hit that like button. It tells me you want more of this in-depth DevOps content.
Okay, so we've got our shiny, tested artifact. Now we're ready for the CD part of CI/CD. But this is where so much confusion happens, because CD can actually mean two totally different things: continuous delivery and continuous deployment. Let's clear this up once and for all.
It all boils down to one single question. Does a human have to press the final go button? With continuous delivery, everything is automated right up to production. The artifact is ready, it's on a staging server, but a person, maybe a product manager, has to give that final manual approval. With continuous deployment, that final human step is gone. If the code passes every single automated check, it goes straight to production. No one touches anything. That's the holy grail, but it requires an insane amount of trust in your tests.
Look, having a perfect pipeline is great in theory, but we all know the real world is messy. Production is where things get unpredictable. So even with all this automation, what happens when things still go wrong? Let's talk about the what-ifs.
This is the question that should keep every engineer humble. No test suite is perfect. There is always a non-zero chance that some sneaky little bug will make it all the way to your customers. So how do we limit the damage when that happens? How do we reduce the blast radius?
The answer is in using smart deployment strategies. These aren't just about copying files to a server. They are carefully designed safety nets. They are techniques specifically created to make releasing new code safer and, just as importantly, make rolling back a failure incredibly fast.
Two of the most common are blue/green and canary. With blue/green, you have two identical production environments. You deploy to the idle one, test it, then flip a switch to send all traffic over. Rolling back is just flipping the switch back. It's instant. A canary release is more gradual. You release the new code to just a tiny fraction of your users, like 1%. You watch your monitoring like a hawk. If everything looks good, you slowly dial up the traffic. This way you can catch a problem while it's only affecting a handful of people.
So let's paint a picture of a disaster. Imagine your team has a test that's a bit flaky. Sometimes it passes, sometimes it fails. You've been meaning to fix it. Well, today, it randomly passes. The pipeline thinks everything's fine and deploys a build with a subtle database bug. Your 1% canary release looks fine, but as you ramp up traffic to 10%, the extra load triggers the bug, and now you're silently corrupting the data for every new person signing up. Yikes.
That little horror story actually highlights a bunch of common failures. Good monitoring should have caught those database errors immediately. And that flaky test? That should have been treated like a 5-alarm fire, because the second you stop trusting your tests, the whole system falls apart. And don't forget slow pipelines. If a developer has to wait an hour for feedback, they're just going to stop committing often, and you're right back where you started.
And all of this leads to a really crucial insight. CI/CD isn't just about tools and YAML files. At the highest level, it's not a technical problem at all. It's a cultural shift in how your entire team approaches building and owning software. The really high-performing teams, they do things like trunk-based development to avoid merge hell completely. They use feature flags so they can ship code to production but keep it turned off for users. Their servers and networks are defined as code. And most importantly, they live by the mantra, you build it, you run it. The same engineers who write the code are the ones on the hook for making sure it runs smoothly in production. That's real ownership. So we've gone through all of this. The pipelines, the tests, the strategies, the culture change. After all that effort, what's the actual payoff? The real value of doing this well goes so much deeper than just automating a few manual steps. It changes the entire business. Let's start with this absolutely wild number from the State of DevOps report. The best, most elite teams who master CI/CD deploy code 208 times more frequently than the lowest performers. Just let that sink in. That's not a small improvement. That's the difference between deploying multiple times a day versus maybe once or twice a year. It's a completely different level of ability to innovate. And here's the crazy part that sounds like it shouldn't be true. All that speed doesn't make things riskier. It actually makes things safer. It creates this amazing feedback loop. You move faster, so you get feedback faster, which makes your quality go up. And because every single change is tiny and well-tested, the risk of any one deployment is incredibly low. You get to have your cake and eat it too. When you put it all together, this becomes a massive competitive advantage. You can ship new features faster than anyone else. You can react to what your users are telling you in days, not quarters. Your developers are happier because they're actually building cool stuff instead of putting out fires. And all of that leads to better products and, you guessed it, happier customers. I want to end with this quote from Dave Farley, who literally wrote the book on continuous delivery. He says that building software isn't like a predictable assembly line. It's an act of learning and discovery. And that's exactly what a great CI/CD system gives you. It gives your team a safe, fast, and reliable platform to experiment, to learn, and to innovate.
If this deep dive was valuable for you, make sure to subscribe to DevOps Corner for more breakdowns like it. And I really want to hear from you. What is your single biggest CI/CD headache right now? Drop it in the comments. Let's talk about it. Thanks for watching.